And something with systems, you've got a lot of components. Can anybody tell me what you have between the components? The network, yeah. So it's this invisible glue. It's the central nervous system. There can't be systems without connectivity or networking or message passing. It's also the part of systems that makes it really, really hard because you have the network fault model. You know, if any of you are familiar with the Jepson testing framework or library, you can just destroy databases just by changing the order that network messages are delivered in. That's all you need to do. And passing that is incredibly hard. It's also interesting because sometimes we think that networking has to be perfect, like we've grown up with TCP as an abstraction, that you must have ordered, message delivery, or you have consensus protocols where you have strict serializability. But sometimes networking doesn't have to be like that. I really like just message passing, like fire and forget, like UDP. That can be really, really powerful too. So I'm really excited to introduce to you someone who has spent their whole life in networking. Started with a bit of physics that Derek will tell you about himself, but quickly went on to work at TIBCO. Does anybody know what TIBCO stands for? Pavel? Yeah, the information bus company, like TIBCO, like you can't get much better than that. And one of my other heroes is Brian Oakey. He pioneered the view stamp replication protocol. He also worked on the TIBCO paper that became TIBCO, the company. Derek was an architect at TIBCO, the information bus company. Then he went on to lead the Google Ajax API team, networking again, in a totally new way, for front end. And I remember as a kid growing up and I was doing Ajax, and Ajax changed everything. There's so many unicorns, they wouldn't be here today if there wasn't Ajax. And then, the Google CDNs, just delivering code to people. And then after that, VMware, Cloud Foundry. I don't know if many of you know, but you're probably all fans of anti-res and Redis. Redis might have been like one of your most beloved databases or code bases. But Derek and anti-res are really close. Derek supported anti-res at VMware. VMware backed anti-res to develop Redis as open source, which is pretty amazing. So, putting data structures into the database and how do you speak to that? So Derek just has such a rich history over so many years. And of course, you'll know he's the CEO of Synadia and also the creator of NATS, which is just, again, messaging. And NATS is pretty interesting because you've got some amazing startups like Fly.io, and they're starting to realize, look, we don't always need consensus in our messaging. Sometimes we just want fast messaging. So I'm really excited to welcome Derek. Thanks for coming all the way from LA.
Yeah.
And excited to hear what you have to teach us about connectivity. Over to you.
Thank you. Thank you. That was very nice. Makes me feel older than I am. I'm going to make some obvious statements. And these are my opinions. And opinions are free, meaning you get what you pay for, so you can throw them away. But they have been formed over a 34-plus year career now, 40-plus years programming. Like Andrew, I think I always love to meet new people and explore ideas. So please come up to me, poke at me, ask me questions, and I'd love to know what you guys are all working on and what is important to what you guys think is coming. I can tell you from my experience that I thought things were moving fast in the 80s and the 90s, and it's not even close to what we're seeing today. And so I encourage everyone as we go from our day-to-day, once or twice a month, I call it popping your head up and go, where's everything going to be in 2 years? And know that the next 2 years is going to be faster than the last 10. And if you say, where am I going to be in 5 years? It's going to be probably more than the last 25 combined. So again, the obvious statements, right? Technology drives our future. Everything that we're touching and everything in the global economies and everything that you can imagine is really being affected by technology in some way, form, or fashion. And from my perspective, technology is simply information flow and access. As we go through the talk, you're going to figure out that I try to make things very simple so that I can understand them. I always have done that. And obviously, this can be exploded out to a 4-hour, conference in itself. But at the very heart of it, it really is simply flow and access. And that information flows through distributed systems. And so, at least from my perspective, every impactful technology is or will be a global multi-cloud and edge-aware distributed system. Every single one of them. Meaning that whatever technology you have as a system component, if it's not accessible on this kind of global scale, you need to make sure that you're thinking about that and how that actually will work. So again, obvious statements. What is a distributed system? Right? It's a set of loosely coupled components that communicate and collaborate. Again, I like simple things. But why distributed? And I think today that kind of sounds funny, and maybe I'm dating myself again. But I really do think there's this notion of looking back to see how we got here. So when I started my career, my first job out of university in 1989, I worked for the Applied Physics Labs at Johns Hopkins University, which is the East Coast of the United States. And I had the absolute worst day of my life, which became the absolute best day of my life. But it took me a long time to figure that out. The reason that it was the worst day was I got selected by the second best physicist at the lab. The first best passed on me. Kind of like me trying to play basketball. Next, And so what that meant at the time was everything in my world was vertical scaling, just by a faster computer. And at the time, the pinnacle of that was Cray computers. And at the lab, we had a lot of those and connection boxes, which I don't know if anyone would remember. And I didn't get a lot of time on those. And even back then on a Cray, a simulation would run, and it would take about 2 weeks to run end to end. And so these physicists looked at me and they said, hey, we've got 12 Spark pizza boxes downstairs. Make them do what a Cray can do. And I said, what? Have you lost your mind? You can't do 12 Spark peaks, the same as a Cray machine. And again, little did I know that what I thought was the worst day of my life became the best day. Everything we do now is distributed computing. And it started with things like, we don't have enough memory. We might not have enough CPU. Everything was usually co-located in a server room, which, again, I'm not a basketball star, as you can tell. So I was also the person that crawled underneath of the floors to do all the wiring, because the wiring was supposedly not supposed to be seen back in the day. But later, of course, it became a latency thing, right? And what I mean by latency, when people say, I understand it, but I don't understand it. And I always try to make, unfortunately, bad metaphors, but it's kind of like if you go into a restaurant, you pay with a credit card, and I said, you're going to have to wait 10 minutes for them to process that credit card. You'd be like, what? That's the way it used to kind of work, right? And so we are now getting used to things being faster and faster and faster. And the human brain has a tolerance around 160 to 180-ish milliseconds, rounded up to 200, which was the golden rule of Google at the time, which meant when the thing enters the front door at Google, if it's not out in less than 200 milliseconds, Larry and Sergey said, nope, try harder. And so what's this have to do with rethinking connectivity? Remember the statement, right? What is a distributed system? It's this coupled components. And what they're trying to do is they're trying to communicate. And for me, again, this is me making obvious statements and simplifying things, but it's the what versus the how. And it's really important that this talk is about the how, not the what. But we'll talk about the what. And so the what is, in my opinion, asking a question and answering a question, or making a statement and processing a statement. That's it. When I go and I give talks to different folks, they say, what do you mean that's it? I'm going, that's it. I can boil everything up in a distributed system to those two things. And you might know them by microservices or event and stream processing and synchronous versus asynchronous and concurrency and parallelism and all these fun things. But at the end of the day, it's literally asking and answering questions and making statements, processing them. And at least in my opinion, even today, the majority of distributed systems, 90% is asking a question and getting an answer back. That's it. And the 10% is event and stream processing. Now, people might argue with that, and I do believe that the 10% is changing quite a bit. But I would also say that stream processing exists solely to get better at answering questions. So if you think about business analytics and then of course machine learning and AI and things like that, and getting access to more and more data, which we'll talk about because it's not in the cloud, it's on the edge, right, so to speak. It's simply to answer questions better. And so this is one that I've been asking since the early 90s. And one of the other themes that you'll understand in this talk is I get a lot of things wrong. Not all the time, but a lot of them. But I always, even in the 90s, was asking myself, well, what happens when the number of components in a system keeps increasing? What happens when it's not 2 things, it's not 4 things, it's thousands of things? And that felt crazy at the time to even think that way. Until in 2003, I went to Google. And the introduction to Google at the time was Life of a Search Query. And it was a 2-day course that you had to go through before you started even trying to apply to write code in Python or C++. And even at the time, in 2003, a query was sitting about 12,000 computers. Now, I would imagine it's easily into the hundreds of thousands. And so I can imagine a world where there's going to be things that are going to be in the millions or billions of things that are all going to be cooperating. And I know that sounds weird, but I promise you it's coming. And so for me, when that keeps moving to a very, very large number, the connections become more important than the components. And so you could argue that that may or may not be the case, but I think there's lots of things that would argue that we have lots of examples that we can look back at that show this exact same trend. We just happen to be in one in terms of digital technology, but this is not the first time this has happened. We'll talk about it in a second. And so again, from my perspective, I think we're entering an age of what I call a connective economy. Most people still think we're in a data economy. That's the most important thing. You hear people say, that's the new oil. Information is the new oil. And I believe that, but if the information is stuck in some computer, in some data warehouse, big data center type stuff, it's pretty useless, at least in my opinion. And so I always ask people, what about rethinking the how? Not the what, asking questions and answers and stream processing and microservices, things like that, but simply the how. And the question always comes up, people have said to me, why? And in the early 90s, we went into Wall Street in the United States, and Wall Street was having a crisis moment. And I didn't understand when I first started working at Technicron, which became TIBCO, what the crisis was. But what was happening is that if I wanted to update people on the price of IBM, it was literally a phone call. And I would hang up, I'd call someone else, hang up, and I'd get to the end and I'd say, okay, price of IBM is there. And remember, with humans and the brain, it's about the best on the planet are 180 milliseconds. And so this and this didn't matter. But Wall Street was about to go into programmatic trading, where it wasn't a human looking at the data, it was a program. And now all of a sudden, Andrew was in a way better position than he was. And so our CEO at the time, this is where I learned the simplify and make it easy to understand. He says, Derek, all we need to do is turn a telephone call into a radio broadcast. And I said, He says, everyone gets it at the same time. And so I believe now, even though financial institutions have been dealing with these types of issues, computers are really fast. And so everyone's like, TCP/IP is fine, HTTP is fine, we don't need anything else. But I really believe that we're at a major inflection point with geodiversity, multi-cloud, edge. And I do believe that, and again, I'm admitting that I'm wrong a lot, or I'm not right for a certain period of time. But I do believe we've already started entering the phase where cloud is the new mainframe. Insurance companies, credit card processing systems still run mainframes and COBOL, but we don't, in this room, probably care about that necessarily. I'm arguing that within 5 years, you're going to feel the same way about cloud. I think edge is the new frontier. I believe that we have been going down this path already, and we just didn't know it, with like CDNs around, image and video resources, things like Netflix, obviously, and now we're starting to see companies like Fastly and Cloudflare and others trying to energize that edge so it's interactive. And again, if you go back to what is a distributed system and what's the what, it's simply trying to make that more automated, more intelligent, and faster. Can I answer the question from inside the car? Or do I have to trombone all the way back to the cloud? What about on the cell tower? What about inside of the house, right? And so, again, probably a controversial statement, but I really do believe that the future that we're going to and where we need to end up is not going to be dictated by HTTP, DNS, load balancers, perimeter security models. It simply will not drive the future that we're about to go into. And again, in my opinion, the state at which things are changing is the fastest it's ever been. And the corollary is, if you see a piece of technology today and you go, that's not really that good, always remind yourself that everything is moving faster than ever it's been, and today is the worst you'll ever see it. Like we were talking the other night at dinner about ChatGPT, and I said, remember, that's 3-year-old technology already. They haven't shown you what the real stuff is yet, which I think Microsoft saw, and that's why they ponied up $10 billion. So the what versus the how. And again, I'm known for really bad metaphors. Don't worry about it. You won't be the first people that laugh at me for it. But I kind of equate it to 80s telephone calls versus Zoom. Remember, the what is not changing. We're giving presentations. We're making statements, right? We're asking questions. People are answering questions for us. But the how has radically changed. From I need to know where you are. I can only talk to one person at a time. You need to be by the wall phone, because this was before even cellular kind of existed, or even the radio headsets, so to speak. And so if you look at the limitations of today's technology, right, there's this notion of addressing a discovery is DNS or host names or IPs. Everything is location dependent. If it's not, they're doing unnatural acts to make you feel that way. But underneath the covers, it is, for sure. It's always implied one-to-one. I was actually involved in the multicast specification. I'm sorry. I looked at the underlying transport, and we did something called PGM with Cisco called Pretty Good Multicast. And I love that. And I totally missed the fact that management at scale was implausible. And so you don't hear about multicasting cloud data centers, right? I think Oracle's cloud and maybe IBM's allow you to kind of do it. Pull-based only. I have to ask you a question to get an answer. Things aren't flowing at me. Front-end versus back-end personas. So what I mean by that is the vehicle making a microservices call to the cloud, and that's the back-end, and whatever's running in the car or on the, the cell tower or on the Cube satellite, or in the charging station in Finland is the front end. And I'm saying those are going to be quickly blurred, and that you want to be able to design a microservice, have it run here, have it run on any cloud, move to a cell tower, move inside of a edge device, whatever that is. Perimeter-based security models, right? At university, which was a long, long time ago, they taught me, if you care about it, encrypt the payload. Don't encrypt the transport. But as things happen with tech, we all encrypt the transport. And I call it the bat phone. We trust the bat phone, right? TLS, MTLS, whatever that is. But that built up this notion of perimeter-based security models. And I believe where we're going, those have to be torn down. But it doesn't mean that you have to give up security. You actually have to up your security level, in my opinion. All of the API gateways, proxies, load balancers, sidecars, if your system needs all of that stuff to run, and I say, I want to stick it on a cell tower, I want to stick it in a vehicle, I want to stick it in a Cube satellite, we're getting to the point where hardware is pretty powerful. And you can run in a closet inside of a store or a retail center. But if you want to run it in a headset, you want to run it, in ever increasingly smaller devices. And the reason that you want to do that is, again, either you're answering a question very, very quickly, or generating data, telemetry data, processing data, right, inside of a headset, in a label maker, which sounds crazy, but I can promise you it's coming. And so as you look at these systems from a perspective of what do we need for this system to function and communicate and be trusted, is that portable? And again, I love HTTP, I really do, But you look at your cellular providers and how they transmit from the cell tower to your phone is not how their backbone works. Yet, for whatever reason, we're like HTTP everywhere. You know what I mean? We'll make it work. And I just don't think it's the future of the intelligent edge. But again, come at me, tell me why you think I might be wrong. And so, for us, we're trying to figure out, how do we push the limits of today's technologies? How do we understand that edge computing is driving this massive transformation to kind of a peer-to-peer connective economy? The other statement that I would make that I think is controversial and it's interesting, but I don't think, as you watch the assumptions around technologies reaching a global scale very, very quickly, that can be controlled by a single organization, company. We've seen it, right? Google, but now it's kind of, a lot of people don't like it. Facebook, Twitter, right? And so what does it mean to look at peer-to-peer economies and really decentralized systems? And I don't have the answer. I have some theories and thoughts there, but I think we all should be thinking in this type of way. And again, we really are transitioning from a data economy to a connective economy. The other thing with looking at AI, which is kind of all the rage, because I think we're maybe not right there, but I think this one's going to stick, right? We're on our path to there. And of course, you hear these things about how much data is needed. What you might think about is that these large companies that have massive amounts of data, huge data sets, Google, right, Apple, Facebook, whatever those are, eventually they're going to run out. And the data sets that are going to be needed to drive something that you think is powerful, let's say on your phone or in your home or in your car, is going to be actually collecting data from all different organizations, governments, all kinds of things. And so this notion of how do we do a secure and hyper-connected, zero trust, I trust you a little bit, I don't trust you at all type of environments to actually drive this future. And I think modernizing connectivity leads to intelligent platforms. And I'll try to give you an example of what I mean by that. And so for us, we look at what are the connectivity pillars. And remember, I'm talking about the how, not the what. So the Zoom versus the wall phone, so to speak. And for us, it needs to be physical substrate agnostic. It used to be that when cell providers were first starting, it was like, oh, do you in the States, do you have AT&T? Oh, I can't call you if you don't have AT&T. Either I can't physically connect to you or it'll cost me too much, right? Nowadays, when you're on a Zoom call, do you even think about where the packet is actually flying? What Wi-Fi or cellular connection are they using? What dark fiber are they going across to actually get there? Is the connection symmetric? Is it asymmetric? You don't know. And you shouldn't have to care, in my opinion. Location independent. This one's a really, really big one for me. I've been on this train since the 90s, and everyone just kind of laughs at me. But I think we've gotten to a tipping point now where it's starting to become important, right? And if you ever have looked at massive, massive system failures from companies that are hugely reputable, always blame DNS. And if not that, it was probably a BGP config update that took it out. Meaning the system was running and it was happily there, but no one could reach it. M2N versus implied, one-to-one. Phone call, always one-to-one. Now you might have a different answer, but for me, I very rarely do one-to-one Zoom calls anymore. There's always multiple people on there, right? And so this notion of M2N becomes really important when you go, oh no, I'm on my laptop, I'm doing a request response to whatever component I'm trying to talk to, I don't care. Just remember, once you're in production, all of a sudden the production people are doing load balancers and firewalls and trying to figure out how to do multi-cloud, and that might take us 12 to 14 months to figure out how to do that type stuff. The peer-to-peer stuff we talked, secure by default. It's not hard these days to develop a system that has no private keys or passwords. It's not. The tech's been around since the 60s, or 50s maybe, actually. True multi-tenancy, I call it the Coke and Pepsi problem, or FedEx and UPS problem. Services and streaming, and we'll talk about that. So we were talking about the what, having those both components. Don't make me pick one technology for one and another one for another one. right? If you get to the point where you're looking at trying to do something that feels like it should be simple, and you've got 25 different technologies just to stand up the first kind of hello world to demonstrate that it works, that should be kind of a little bit of a light bulb going, we might want to figure out how to simplify. And as systems get larger and larger and larger, simplification is really important. Or at least the understanding, as Andrew said, understanding all of the moving pieces, understanding how the system actually works. I call this intelligent persistence, and I'll explain a little bit more about what I mean by that. And then extensible and global. Again, I think things are going to be decentralized. So why can't I buy my own cell tower and stick it in my backyard? Why? You can. In the United States, you can get these little things called mini-tels or whatever like that. But I mean, in general, this notion of, ooh, I want to be able to extend whatever this service that you're providing for my own usage, either personalized through the data, which we're going to start seeing a lot of, right, with the AI revolution around, it'll learn you and layer that over top of very large trained models that took hundreds of millions of dollars to train. And so, yeah, I think as people are also designing systems, always think about how your users or customers want to extend it and personalize it. So we're going to talk quickly about fundamentals, topology, security, and persistence. The fundamentals, again, location independence, end-to-end, a utility versus a silo. So what I mean by that is you have your own version, you have your own version, you have your own version, you have your own version of the exact same thing, whether it's a database, a key value, a messaging system like from the 90s that I was involved in. I really think moving to kind of a utility model or a SaaS model is super important. I'm a big believer in self-healing. The system should be able to put itself back together. It should not need an army of people. And Google kind of beat that into me. I remember when I joined, they didn't have their own data centers yet. They still contracted out. But it was amazing to see that. And then 2 years later, as you walked in, all the lights turned on. The lights weren't on by default. It was literally a lights out operation. And at the time, I think Google had the best metrics of the number of people per number of computers to manage. And it was like 2 orders of magnitude better than anyone else right on the planet. And so when I think of that, it's like, how can the system and the software working with the hardware self-heal itself, put itself back together, such that the application or the components within the system, they go, hey, can you do this for me? And it says, yes, I can do it for you, and it's done, right? With all of the caveats there. And of course, physical substrate agnostic is super important. Topologies. What I mean by this is pretty simple. Please don't tell me there's one big thing in some data center on AWS East or whatever, right? I should be able to just get these things wherever they are. And it's either, again, on the microservice or access the data that I need. For a messaging system, the biggest one of the things we did with NATS is that the server is very lightweight and it's not a pet, it's like cattle. And you can Lego brick these things together any way you want. And people that don't even operate your core system, they can extend your own network and operate their own servers and keep making satellites and, go ad nauseum to that. Pervasive, meaning big to small. What I mean by that is systems should be able, in my opinion, be able to run on the biggest computers that Amazon and Google and Azure have to offer, and it can run on a Raspberry Pi 02 or even smaller, an ESP32, is where right now we can run on those fairly well. Decentralized, as we talked about, and extensible. Security, this one feels like a no-brainer, but it's just not. No keys or passwords. Don't put keys or passwords in systems. Securely multi-tenant, which is a whole topic unto itself of how do you really actually do that, where, at least in our world, you're in your own, we call them accounts, but secure membrane, and you can communicate no matter where you are in the world, no matter what cloud provider, it doesn't matter. But more importantly, when we say secure multi-tenant, we also have secure sharing. So you're allowed to actually figure out how to share data securely, and you can trust that, Larry. Secure data in motion at rest, and then again, the zero trust constructs are going to be really important, and it's still developing what that really means, but it's a big deal. So thinking about, can I interoperate or extend my system to operate with another system that I don't trust, and what does that actually look like? So for persistence, as much as I think systems moving from cloud to edge and the cloud is the new mainframe, I think it's going to have a profound impact on data. So what I mean by that is the massive databases and the massive data lakes, I also think are the new mainframes. And that I think that intelligent data that can flow and move and is secure to wherever it's needed is going to be really important. And so when we looked at adding persistence into our system, we didn't want to reinvent the world. And we didn't want to do relational stuff. We have some talks about that. That's a whole company on itself, which is amazing. But we did say, if the application developer is looking at persistence, what do they care about? They care about what we call materialized views, key value stores, object stores, a globally ordered set of transition events, messages, whatever you want to call it. But I should also be able to asynchronously create digital twins and what we call source muxes and demuxes anywhere in the world. And that these are all interoperating and self-healing. And so you start to get to the point of when you say, oh, once, for example, in the United States, I know this sounds goofy, but once we all had electricity, then all of a sudden this Cambrian explosion started happening of, oh, there's always a wall socket. We just plug stuff in. And I really think there's an opportunity here for that as well. We talked about this, single message, globally ordered, key value store, object store. But what's interesting is the reason I asterisked globally ordered set of messages is that if you have a system that can present on a global scale a globally ordered set of messages, any external data store that can be described in a globally ordered set of messages, change data capture, systems like that, means that even though you don't want to own the data, you can actually make it intelligent. You can create digital twins all around the world. You can move and mux and demux and things like that. We talked about this. And so an example to give a little bit of, a sense. So we had a customer come to us and said, hey, we want a horizontally scalable, multi-geo, multi-cloud, edge-aware. Edge for them was partner sites, bank sites, things like that. That requires key value data that has less than a 10 millisecond latency worldwide. And we have 24 months to get it, but we really want to get it done in 3 months. And we're going to start with 50 million accounts, but it's going to quickly go to probably 200 to 300 million accounts. And I'm not here to tell you that you can't do it with existing technology, but it's kind of like an internal combustion engine versus an EV. I think there's a better way to do things. And so we actually showed them a concept in less than 20 minutes on the same call. We just fired it up. And they're like, oh. They said, well, what about, if it's our systems, right, our partner sites? What happens if we want to do that? And we said, hey, start up a server. And they started up a server, extended the network that we were doing on the call, and then all of a sudden the key value stuff was there. And the system that was asking for the data, right, in our little POC, which was just the CLI that everyone uses to control a system, they were asking for it, and all of a sudden it went down to less than 1 millisecond without reconfiguring, without restarting. And so it's a different way of thinking about the how, not the what. And so the how today, again, I'm not saying you can't do it today, but non-trivial DNS with pinning or anycast, load balancers, firewalls, API gateways, traffic shapers, cross-cloud SecOps. If you are developing and starting a company and you're developing a product, know that the first people that you want in the room, you want to ask for them to be first in the room as the security people. They have all the power now. They can stop you cold. And so you're going to have to deal with that, especially around multi-cloud. Most of the time you have to have a PhD in cloud security ops that's tailored to a specific cloud provider or now edge provider, right? There is no homogeneous way to do that traditionally. Federated, whether it's K8S or service meshes, they usually reach a limit where they start to fall down. And even our system, I've been working on these now for 30 some years. They're not perfect, but we did have someone say, I want true location independence for 1 billion things. And to be honest with you, 1 billion things, if someone comes to me with 1 billion things, it's either people or little teeny devices where they're cross-cutting across different organizations. And we can't do it yet, but we're really close. And we are doing easily tens of millions, and we're starting to do hundreds of millions of these things worldwide. And so, a replicated key value store, whether it be old school Memcached or Redis, Salvatore is a good friend of mine. How do we actually figure out how to do that? And then whenever I say, oh, it's not the cloud provider, it's not in this VPC, it's in this store, in this distribution center, in this train, in this truck? Do they all of a sudden their faces just drop and go, oh, well, we can't do that, right? And so rethinking the how, I believe there is an opportunity for an extensible federated connective mesh. And what I mean by that is that lots of companies are running this stuff. So I had a reporter a couple of months ago said, if you're ultimately successful, what does your company look like? And I said, if we're successful, we look kind of like ARM. We're the steward of a technology, but we don't run very much of it. The cloud providers of the world and the edge providers of the world and low Earth orbit satellites of the world run these things. And anybody can extend them at will. And there's these constellation satellite points that all of a sudden generate systems like Slack or like a Twitter replacement or whatever you're talking about. I've done a couple deployment systems. Cloud Foundry was one that was mentioned by Joran. And I said, I don't want to do another one. I've done 3 now in my career, but I don't think we have it right yet. I'm not saying that I'm the one to do that, but I don't think we have it right. I don't think K8S is the answer. And so we've been starting to rethink, how do we actually do this? What does it look like? How do you declare intent? Thresholds, again, in a zero trust infrastructure system. But again, if the how is different and you can say there's always a plug that I can plug into and it always kind of works, you can think differently about how those types of things work. And at least for me, any system should be able to be deployed in any type of environment. It shouldn't require one. Again, I know a lot of, if you're into the cloud and the CNCF, which we're a member of, I'm sure that would be like, no, we got to do service mesh and gateways and stuff like that. But I really think as system designers, it should be able to run in whatever the soup du jour is of today, but it should be able to run on bare metal and inside of Raspberry Pis and VMs and containers and WASM and all that kind of fun stuff. And so where are we headed? It's interesting. Again, when I started my career, you could go into a server room, and these were the ones that were super cold. You had to wear a little parka to go into them. They maybe had like 2 racks, 3 racks. And everything you saw, the blinking lights, were either the disk spinning rust back then or the CPU. And they actually hid the wires on purpose. And you couldn't see them. And in the 90s, when we were doing a lot of stuff in Wall Street, even though the server room started getting bigger and bigger, I could still go in and point to the exact machine that I knew our technology was running on. It's like, oh, I know it's right there. If you go into a modern data center and the lights turn on, all you're going to see is cables. And remember I said this isn't necessarily unprecedented. If you look at kind of these waves, the way I like to characterize them is that there's a wave of physical connectivity followed by a small enablement wave, although I think they're getting bigger now, and that's where we play, followed by a Cambrian explosion of stuff that no one could have figured out, right? So the early DARPA networks between universities and research facilities that then became the internet, which in 93, 94, 95, I saw it coming and I was so excited, and I was totally wrong about what was about to happen. And I thought I knew, hey, this is going to change the world. And it did, but in ways that no one could have predicted. The cellular networks, right? I hope my phone works when I land in London, it was always our big thing. And then the global cellular networks all of a sudden became not only possible, but now we just assume that they work all the time. And everyone's like, okay, 5G, 6G, whatever that is. But low Earth orbit satellites are changing the game again. And I think they're going to disrupt all mobile providers, CDN providers. I really do. But this physical wave is, again, leading to even more and more hyperconnectivity. We believe we're trying to be this enablement wave. We don't believe HTTP and TCP can foot the bill anymore. And then we're going to see a Cambrian explosion of connected things, data flowing around, and machine learning AI within, I think, the decade that will blow everybody away. And I'm super optimistic, as the people that I've been chatting with on this trip so far know. And I can promise you I'm probably wrong on the wrong side, meaning I'm probably not optimistic enough. I might be wrong on the time, but I don't think I'm wrong on the optimistic stuff. And so I believe kind of the future of these distributed systems, where Jorn was saying the connectivity piece, not the component piece, right? We talked about components and the network and the connectivity piece. I believe they're going to be driven by connectivity. I think they're radically going to change. It might not be the technology that we're working on, but something is going to come along, kind of like HTTP did in a little bit of a ways, right? That's just going to fundamentally change the rules of how these things all connect together. Transports and encodings, I think, will disappear. At one of the dinners, we were talking about, my information is very dated. I left Google in 2010, but you know, there's reports that 5 or 6% of CPU load globally was on hashing. And there was another one on protocol buff encodings and decodings. And then the people that wanted to use JSON, it was even higher. I think that all disappears. And if it doesn't disappear, meaning it's actually still happening, you're not aware of it. You're not actually even using technology like ours and saying, connect to this thing and, you know, say I'm interested in these types of messages. And then I know they're coming in JSON or Parquet or Protobuf or Message Pack or whatever. There's going to be a huge deal around zero trust. Again, the multi-part exchanges, which sounds weird, but think about where the next data is going to be coming from. You're going to have to start pulling it from all different types of places. I do believe perimeter security models disappear, or they get extremely dynamic where you don't feel like it's a perimeter security model. I do believe ML and AI will drive demands for intelligent connectivity. We're already seeing with a lot of our customers the ability to not only generate data and run inference engines on that data on the edge. And it's like, okay, but how do you get the inference engine there? How do you get the telemetry data back? How does it get trained? How does the inference engine get updated and then distributed out on a global basis? And that's where, when I talk about the how and that electric plug type thing, it's always kind of there. The rules kind of change. And it's not necessarily that it radically changes, except for the time frame. The time frame radically changes. And I think technology is not only about innovation, but it's also about velocity and speed. And then again, this one's one where I get a lot of people pushing back, but I really do believe there's going to be these massive data lakes and massive training sets in the cloud. And whether it's key value stores or you're in Tiger Beetle's, you know, database or relational database, you're going to see a very quick trend where they keep shrinking and they can move all the way out into the edge. And if you follow companies like Fly.io, you know, they kind of have this notion already with SQLite, where they can actually stick it all the way to the edge and have it asynchronously updated. And Fly.io doesn't use our tech for that, but they're looking at it now because companies like HarperDB did that with a technology that we helped out. And so rethink connectivity, think about the how, not the what. If you want to learn more, these are some links, and I'm happy to talk to you about them, but this is not about that. But if you are interested in how we approach trying to solve some of these problems, feel free. And thank you. I appreciate it. Happy to take questions.
Oh,
Make them good. Make them juicy.
I was just going to ask you that question. If you would. Yeah.
Yes.
Hi. Something that I think is implicit in all of this is that. Wait. Hi there. Something that's implicit in all of this, at least from my perspective, is that it's pretty much all running on Unix-alike networking stacks. Do you think that Unix-alike networking stacks can accommodate where you think this is going? Or do you think we'd maybe start to see that low-level stuff being reworked?
I think that's a great question. And we actually had a conversation a little bit at dinner the other night around TCP/IP versus QUIC. And I was kind of laughing to myself because I started my career around reliable UDP. In the 1990, 91, 92, that's what I was designing. It was called TRDP, Technicron's Reliable Datagram Protocol. And I could have swore that I would never see UDP make a comeback. What I think the most important thing is it shouldn't matter. Not at this semantic level. So in other words, someone says, oh, QUIC 3 is going to be faster in XYZ. And I say, well, if you amortize the cost of a TCP connection and you're low RTT and good signal noise, it'll win every day. But if you're constantly making connections and you don't amortize that cost on, let's say, TLS, the BAT phones, right? It was a three-way with TLS 1.3, tried to be a two-way. Now I think QUIC can do it on a one-shot, right? So it does help. But if the semantics that we're talking about, it shouldn't matter. That's that physical substrate agnostic. I actually include the OS layer, what was those crazy layers, the 7 things that we had to learn, and the OSI layers and stuff. And that includes whether it's, TCP, quick. For example, we extend out so you can natively take and allow MQTT to immediately connect directly into this, or WebSockets. So we just think it needs to be pervasive, and the semantics is what matter as long as the underlying system works. And quick probably is a good answer. We have a very large retailer the largest actually in the world, that melted one of their computers down because NAT servers, even though they're really small and you Lego brick them together, they can hold hundreds of thousands of connections, no problem. But this company was in old school RSA 4K keys for Diffie-Hellman. And they had a server that they were so excited about, had 60,000 connections on it, fail. And they all tried to, run on the bank onto another one. And it literally melted a 4-core, not true melted, but you know what I mean? It just killed it out. And so that's where you say, oh, to meet the things, maybe ECC keys, maybe quick, things like that. So I do believe it's going to play a role. And we've been watching it really closely, but it's also kind of trailed off a little bit. I mean, we know it's built into the Chrome browser and things like that, but whatever makes the most sense. Great question, though.
I have a question around identity, because my understanding or like impression of I think one of the core problems in kind of distributing computation across like vast amounts of computers is how do you trust that the computers are actually doing what you think they're doing? So I guess to summarize, I guess like what I'm curious about is how do you handle dynamic topology changes and still maintain like strict authentication identity like in your semantics?
Yeah, so that's a great question. And I do believe hardware attestation plays a big role. I don't think we're there yet. I think IoT will get there quicker. The stuff that Intel did and with the enclaves and stuff, I don't think it hit the mark. But in our system, it's not necessarily that we're radically different, but what we try to do is radically simplify the things that we know work. So public-private key stuff, it's just math. But if you attach it to a claim like a JOT that says what you're allowed to do, now suddenly it's like, oh, okay, I'm claiming that I do this. And then there's a chain of trust. And so in our system, you go from a user or an application of what it's allowed to do into an account. That's the membrane, the isolation context, where we're free to chat as much as we want inside there, and we have to do special things if we want to go across that membrane, like an API layer. And then there's the notion of the operators. And what I mean by an operator is I'm running, let's say, a server, a NAT server. I tell that server, here are the public keys from the operators that I want you to trust. I don't care how the user was created. I don't care where it was created. It was Google, Verizon, Starlink. I don't care. But if that chain of trust comes up, trust it. And the other thing that I care deeply about was I felt that revocation was never done correctly. And so our system is real-time revocation. I'm not saying that our system is perfect. I'm just saying I believe whatever's going to win needs to have that, and it needs to really work at the speed of light. It's like, oh, Derek's a bad actor. Click, done. No matter what, no matter where, what servers, what clouds, wherever they're running. And so we just try to trampoline off of things that are known. Public, private key stuff, claims, we use JOTs, but whatever comes down the pipe. And a very simple, understandable chain of trust and real-time revocation. Yes?
Hi. Yeah, I wanted to ask whether, as we trend more towards edge compute, whether we'll see an increase in more specialized hardware and ASICs for stuff like trusted execution, trustless execution environments, and I guess multi-party computation.
Yeah, great question. At least from our view of the world through our customers, we're starting to see a lot of security constructs around HSMs, for sure. Not as much custom ASICs unless we're in the IoT world, but then there's a standard either the PLI or the MQTT, right, to kind of get data in there. It's amazing how powerful a system is today that could run in a closet in a cafe or run inside of a charging station. The things that run at the base of a cell tower that we operate in are more powerful than the craze that I couldn't work on at the applied physics lab. And so we're starting to see more of a standardization around that. Also, the whole hardware infrastructure from at least chip manufacturing is now going through another renaissance, right? We kind of flattened a little bit. You know, I think Natalie and I were talking about that. We flattened for a while on Moore's Law. Now we're getting another kick with ASMLs, EUV machines coming out. You're going to see just craziness. And it's not only that it's fast, it's like super energy efficient. So we're watching the trends around energy efficiency, HSMs, but we don't see a lot of custom ASICs outside of IoT4 and manufacturing.
And just a follow-up, I wanted to ask, like, whether you think zero-knowledge proof systems may play a big role in sort of this trustless communication.
That's a great question, and I have an opinion, but I don't have an answer. But I'll give you my opinion. If I could tell you that whenever you used your credit card, it was guaranteed to be perfect every time, no one could ever steal it, you would never get charged incorrectly, but it would take an hour to do it every time you use it, would you use it? And the answer, the answer is probably not. And so what I think you're going to see is ZKs will start playing a role because they're really interesting in this multi-part exchange that I talked about. And we've been following them, and we've been watching some of the non-bad crypto stuff, but in the ZK type of space. But what we also see from the crypto space that, again, nothing's really ever new. It's always kind of repeating. It just looks different. But we realize that, at least we believe, and it's starting to prove out, there's going to have to be tier 2 and tier 3 change because the velocity at which transactions need to happen, like if you look like at a Visa or a MasterCard and then say put that on, you know, a mainnet, even proof of stake, no, right? And it's also too costly in terms of energy and stuff. So I think you're going to see ZK play a role in kind of connecting big backbones together, big parties, right, that kind of have a stable relationship. I think all the things that change at a very rapid rate out further towards the edges, I think will probably, I'm guessing, but it's an opinion, you know, you get what you pay for, that they're going to optimize for user experience and latency and speed, not correctness.
Okay, thanks.
Shall we do one more, Luis? Yeah, I can use mine.
I have a question about deployment systems. What do you think is the most ideal deployment system for this kind of model where you have billions of devices that need to be changed? And humans, deployment systems are an interface for humans and automation. But what does that actually look like? Since I agree with you, we're not there yet.
Great question. And my answer comes from, if we can change the assumptions, do we change what's possible? Okay, so what I mean by that is, again, in our world, which might not be the world that we get to, but it's going to look something like that, more so than what it looks like today. But if you say to yourself, hey, with a single NATS connection, right, I can do microservices, load balancing, GSLB, zero trust, security, streaming, stream processing, persistence, KV, object store, blah, 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 right? One could imagine a world where you say, oh, whatever I want to run, I'm going to wrap it in a little, you know, firecracker, you know, VM, which are super fast, or maybe a container, maybe WASM, whatever. But it can't access the, you know, the file system. And the network is provided by the outer layer. You have no say in it. The outer layer, the operator says, I want to run one of these things. I want to run it in my house. But it can only extend that network. And when I extend that network, they actually give me tamper-proof credentials. That's the only way I can interact with that. But then anywhere in the world, you can say, oh, I want to run a workload. And whether it's declared intent, which is I want to run it there, I think that world's going to see to follow around where the requests are coming from. Follow this KV around, because wherever the KV is, I need to be. Follow him around, because these microservices communicate and talk to each other all the time, so we like to be a pair. So I think the world might look like that. And I don't know if I care if it's WASM or still containers or functions as a service. But the thing that's really interesting to think about, and I think all of us are in technology, is things are coming very fast, which means that you can be a little bit more cavalier with trying to be revolutionary versus evolutionary. Back when I started, if you know, there's some crazy smart people in Silicon Valley, but they jumped too far ahead, and no one could make the transition. They couldn't see the deal. A world where it's like, oh, I want to run this thing, and I know from an applications perspective, I need access to this KV, and I need access to this other microservice, and I'm going to be generating telemetry data, you know, whatever. That can all be potentially satisfied with a very different system, but again, on the how. The what's still the same, right? And so we're thinking of a world where the security model is inherent, because the only thing you can do is whatever the operator's container is allowing you to do. In other words, you can't even say, I want to open a socket or create a socket. It's literally, it is what it is. So if you're going to run in there, you're connected to this global network or this federated network or whatever that is. That's kind of my guess. It's interesting because I lived through the pass to the IAS, you know, IAS pass and back to IAS with, you know, Cloud Foundry. You know, I don't know if anyone's heard of it, but it was my idea of Heroku for the enterprise. That's it. I mean, it was cool. I liked it, but I could also tell it was too opinionated. And so what we care deeply about is if the opinions don't affect what you can do, then they might be good. So again, I can do KV, microservices, load balance, all that other stuff, but underneath the covers, it's very opinionated. You can't access the file system, the network, anything like that. So that's kind of where I think we're going to go. We'll see.
Thanks so much, Derek.
Thanks, everyone. Please come up. I love, you know, listening to people and getting an understanding of what everyone's doing. And so, yeah, I'd love to debate. If you think I'm wrong, please let me know. It's fine.
Thanks so much. Yeah, huge round of applause for Derek.